Today we're going to talk about the equations for parabolas, a specific type of conic section. First of all, the definition of parabola is a collection of all points that are equidistant from a fixed point called a focus and a fixed line called a directrix. So in this diagram over here, and you can fill this in on your notes, here's the parabola. This is the collection of points. Here's a fixed point called the focus. Here's the fixed line called the directrix. And all of the points on this parabola are the same distance from the directrix as they are from the focus. This specific distance here from the vertex of the parabola to the focus, this distance is A. So when we look at the equations for our parabolas, A is the distance from the vertex to the focus. This segment that goes through the focus and is parallel to the directrix, this segment is called the latus rectum, and it has a length of 4A, which you can see shows up in the equations for parabolas. These specific points here are the end points of the latus rectum. And here's the vertex. All right. So our parabolas come in two different forms. Opening up and down, which we've seen before. So parabola opens up, parabola opens down. The vertex can be all over the place. In this situation, the equation for the parabola is x equals x minus h squared equals positive 4a y minus k. So the a value is positive, that's opening up. hk, that would be the coordinates of the vertex. And then remember, a is the distance from the vertex to wherever the focus is. If your parabola is opening down, it's still x minus h squared equals, this time it'll be negative 4a because it's opening down, y minus k. Now, it's easy to remember that the equation is this form because we're used to parabolas opening up or down, and in that case, x has to be squared. So we can remember the x squared comes first when the parabola is opening up or down. Now in conic sections, the parabola can open right or left. So here's a parabola opening to the right. Here's a parabola opening to the left. And when the parabola is open right and left, now the equation is going to start with the y squared. So if it opens to the right, y minus k, y and k always go together. This will be equal to positive 4a x minus h. X and h will always go together. And again, the vertex is hk. If your parabola opens left, we're still going to start with y minus k squared. But this time, it'll be equal to negative 4a, just that reflection, x minus h. So these are the four forms of our parabolas. So you'll need to figure out a way to remember which equation goes with which. Let's take a look at our first example. We're going to find an equation and make a graph for a parabola with a vertex at 0, 0 and a focus at 5, 0. So first I'm going to put my points on the graph. 0, 0 is right here. It's helpful to label that V for vertex and the focus is at 5, 0. Remember, 5 is out along the x-axis. Don't go the wrong direction. And I'm going to label that F for focus. That way I won't lose track. So what I can tell already is that the graph, the parabola, is going to open to the right. So I already know what form of equation I'm going to use. Y minus k squared, positive 4a, x minus h. Remember, the vertex is hk. So those are 0, 0. That's nice. And also remember that a is the distance from the vertex to the focus. So in this case, the a value will be 5. When I go to write my equation, k is 0, so this will just be y squared. A is 5. 4 times 5 is 20. H is 0, so this will just be x. Here's the equation for my parabola. Now I want to make sure that I draw this accurately, so how wide will it be? In this case, I need to remember that the latus rectum, this segment that goes through the focus and is parallel to the directrix, is 2a from the focus on each side. So I go to my graph and I use 2a, which is going to be equal to 2 times 5. So from the focus, I would go up 10. There's one end point. Down 10. There's another end point. And then my parabola curves like this. Remember, this distance is 2a. There's one more thing I want you to add to the graph that wasn't mentioned here, and that would be the directrix. The directrix is on the other side of the vertex, 5 units away. So here is the directrix. I'm going to label that directrix. All right, let's review. A parabola has a vertex, and then on one side there's a focus through which the latus rectum goes to show us how wide the parabola is. On the other side of the vertex there's the directrix, and all the points on this parabola are the same distance from the directrix as they are from the focus. The vertex in particular is a units away. So when I plotted my vertex and focus, I found a, and then I could set up my equation. Let's try the next one. We're going to find and graph an equation of a parabola with vertex at 0, 0 again. So 0, 0, label it V for vertex. Focus at 0, negative 6. So be careful here. You're going to go down onto the y-axis, 0, negative 6. Label that focus. This time the parabola is going to be opening down. That would be this form of the equation. Opening down starts with x squared, and it has to have a negative 4a. So I'm going to copy that down right here. X minus h squared equals negative 4a y minus k. Remember, h always goes with x, k always goes with y. I know the a value right away because that's the distance from the vertex to the focus. H and k are both 0. So when I write my equation, this will just be x squared equals negative 4 times 6, which is negative 24, and y minus 0, which is just y. One thing I want to mention is the a value is always positive because it's considered a distance, and distance is positive. To finish my graph, I'm going to sketch the latus rectum. And remember, from the focus out to the end points of the latus rectum is 2a. If you didn't remember that, look back at your diagram here. 2a from the focus. In this case, that would be 2 times 6, 12. This is going to be a little bit off the graph, so I go 12 this way, 12 this way, and then I sketch my parabola. The other thing I'd like you to add to the graph is the directrix. So remember, the directrix is the same distance from the vertex as the focus. So I go up to 6 and draw in my directrix at y equals 6, directrix. Let's try something where we have to write an equation for a parabola. So we're given the vertex, at 0, 0, so I've got an HK. We have a point on the parabola at 1, 2, it's just an XY point. We aren't told that this is an endpoint of the lattice rectum, so we can't assume that it is an endpoint of the lattice rectum. My parabola is opening to the right, so that basic form is y minus k squared. Whenever it opens left and right, remember to start with y squared. Positive 4a x minus h. And now I'm going to substitute in what I know. I know 0, 0, so that's h and k. I have an xy point on the graph, so I can put 1 in for x and 2 in for y, and then I'm going to solve for a. So 2 minus 0 squared is just 4, 1 minus 0 is just 1 times 4a, a is 1. So when I write my equation for this parabola, here's my basic format again. So it'll be y minus 0, which is just y squared. A is 1, so I'm going to do 4 times 1. X minus 0, which is just x. Here's the equation for my parabola. Now, it turns out that because A is 1, here's the vertex, here's the focus. This actually was an endpoint of the lattice rectum, but we can't assume that because we weren't told that specifically. Let's move away from a vertex at 0, 0 and instead find and graph an equation for a parabola with a vertex at 2, negative 3. All right, vertex 2, negative 3, remember this is h, this is k, and the focus at, I'm going to label this focus since that word is way over there, at 2, negative 5. So plot your points. 2, negative 3, label it F for focus, label it V for vertex. 2, negative 5 is the focus, label it F for focus. And now you can tell which direction the parabola is going. It's going to open down. See if you can remember what form of equation that parabola will have without looking back at the front. It's okay to flip back once you make your, see if you can remember. Opening down starts with, x minus h squared. Because it opens down, it's going to have a negative 4a, and then y minus k. I know the distance between the vertex and the focus is 2, so automatically I've got my a value is 2. When I write my equation then, x minus h is 2. Negative 4a will be negative 4 times 2. And then y minus k, in this case it would be minus negative 3. Here's the equation of my parabola. A few other things I want you to add to your graph. The directrix, which is just on the other side of the vertex, same distance away as the focus, so 1, 2. Here's the directrix. Write an equation for that. It's horizontal, so it's y equals, in this case, negative 1. And then in order to finish sketching the parabola, you need to draw in the latus rectum. So remember, the latus rectum is the segment through the focus. And all I have to do is go over 2a on both sides. So 2 times a is going to be 4. So I come out 1, 2, 3, 4. Other way, 1, 2, 3, 4. And then I can sketch my parabola. Next one, we're going to write an equation of this parabola. We don't have to make a graph this time, but sometimes it's helpful to sketch a tiny little picture so you can see which way it's opening without having to really think about it too much. I'm going to write an equation for a parabola with a vertex at 3, 3. So 3, 3 would be somewhere up here. A focus at negative 6, 3. So negative 6, 3 would be over here. So I can tell from my tiny little sketch that my parabola is going to open to the left. Think about what form of equation that is. When the parabola opens left or right, it's going to start with y squared. So y minus k squared equals negative 4a x minus h. Here's the vertex, so we've got an HK 3, 3. I need my a value, so keep in mind we're at 3, and over here at the focus we're at negative 6, so the a value is 9, and now I can put that all into my equation. Y minus 3, because that came from the vertex. Negative 4 times a is 9, negative 4 times a is negative 36, and x minus h is 3. Here's the equation for my parabola. All right, one more. We're going to write an equation for a parabola with a focus at negative 4, 4. So keep in mind this is the focus, not the vertex. And the directrix is the line x equals 2. Sketching a picture is very helpful. Negative 4, 4. I'm going to label that F for focus so I don't forget that's the focus. The directrix is the line x equals 2. That's a vertical line. And because the focus is here, the vertex is somewhere in the middle. I have to go exactly in the middle. 1, 2, 3, 4, 5, 6. So half of that, the vertex would be right here. Remember, the vertex is the same distance from the focus as it is from the directrix. So the coordinates of my vertex are negative 1, 4. So that'll be my HK. And I can tell from my diagram, my parabola is going to open to the left again. So I'm going to use the same format I did before. I need my A value, which is 1, 2, 3. And now I can put it all together. So y minus 4 squared. Negative 4 times 3 is negative 12. And x minus negative 1. There's the equation of my parabola. Last thing we're going to do before the word problem is convert in from standard form back into vertex form. So a couple things to notice. We've got a y squared and then just a plain old x. So that means I'm going to have something in this format. Also notice that x and y are on the same side of the equal sign, whereas in our vertex form we have y on one side, x on the other. So the first thing I have to do is rearrange things. I'm going to keep my y squared and minus 4y on this side of the equation, but I'm going to subtract everything else over to the other side. Then, in order to get a perfect square here, I need to complete the square. So y squared minus 4y, fill in the blank. And whatever you add to one side, you have to add to the other side. Don't forget the pattern here is to take half of the b value and then square it. So half of 4 is 2, squared is 4. Whatever I add to this side, I have to add to this side. I'm almost there. I'm going to factor this. So this becomes, I made it a perfect square, y minus 2 squared. When I simplify this, negative 4 plus 4 is 0. Let's get equals negative 4x. Now I have vertex form, and from here, I can find the vertex, focus, and directrix of this parabola. So remember, the vertex is hk. H is always with the x. In this case, that would be 0. K is always with the y. In this case, it's 2. So here's my vertex. In order to determine the coordinates of the focus and the equation for the directrix, I need the a value. Remember, this is equal to, so negative 4 is equal to 4a. Let's see, which way is this opening? This is opening to the left, so that would be negative 4a. Then my a value has to be 1. So that means that the focus is 1 unit away from the vertex, and the directrix is 1 unit away on the other side. It helps to have a little picture here. So I'm going to sketch my picture over here. I know the vertex is at 0, 2, 0, 2. Label that vertex. When I look at this equation, I know that it's going to open left. Starts with a y squared, so that's either right or left. It's negative over here, so that means it opens left. The a value is 1, so I know the focus is 1 unit away from the vertex inside the parabola, and the directrix is 1 unit away on the other side of the vertex, on the outside of the parabola. So the directrix is x equals positive 1, and the coordinates of the focus are negative 1, 2. Last but not least, this is one example of where a parabola equation would be helpful. So we've got a TV satellite dish, and it's in the shape of a paraboloid of revolution. This simply means you take a parabola and you revolve it around its axis of symmetry, and then it makes like a 3D dish, satellite dish. For our purposes, we're just going to draw a 2D. That's all we need. I am drawing it so it opens up because I'm just really comfortable with equations where it's x squared and a positive 4a times y. I'm also going to picture this on an xy axis so that the vertex is at 0, 0. Just makes the equation simpler. You can put this anywhere. You can put the vertex anywhere, but I think h and k being 0 makes my equation a lot simpler. All right, we're supposed to find the location of the receiver, which is at the focus of the parabola. So somewhere in here is the receiver, and you can see this on your own satellite. Remember that like as the rays come in from the satellite, they the focus or the receiver receives the rays, and then they bounce off the parabola, and that's how you get your TV picture. So here's the focus, and we know a few things. We know the dish is 6 feet across at its opening, so it stops. So this is 6 feet across. This opening is not necessarily the latus rectum. You can't assume that. So just kind of be careful here. So it's 3 units this way, 3 units this way. And it's 2 feet deep at the center. So here's the center. So from here to here, it's 2 feet deep. And the focus or the receiver is somewhere inside the dish. Okay, so I need to find the A value. If the receiver's at the focus, I need to find the A value. How far away is the receiver from the vertex? Here's my basic setup, and I chose this because it's opening up. So 4A is positive. HK is 0, 0, so I don't have that in here. And now all I need to do is calculate A. In order to do that, I need an XY coordinate point that's actually on the parabola. So don't be tempted to use this point here, because this is not actually a point on the parabola. Okay, here's the parabola, here's a point, and here's a point. Let's see, so this coordinate point, if you want to go to the right, is at 3, 2. Got that from these numbers. You can use this one over here. This one would be at -3, 2. Doesn't matter which one you choose. I'm going to use the one with positive coordinates because there's less chance for mistake. So I put 3 in for X, 2 in for Y. Do a little simplifying, and I find out A is 9/8. If you want to change it to a decimal, you can. I believe that's going to be 1.125. So I know the A value. This means the receiver is 9/8 feet from the vertex. Let me know if you have any questions when I see you again.